welcome to my presentation. We keep you safe on the road. How this works, I will show in the presentation, and therefore I will introduce our project results from the RELAI project, risk estimation with a learning AI. My name is Freudenmann. I'm from EDI, Engineering Data Intelligence. We like to semantically link the data and provide AI-based decision models. This is what we are also doing in this project, but also we work together with other partners here from Fraunhofer and University of Stuttgart, and also with IPG. So it's I think everybody knows IPG car maker. It's a well-known vehicle simulation environment, especially also to test autonomous vehicle systems. What is our motivation? So I think everybody knows 90% of all accidents happens because we have not the right speed. But the right speed depends on the driving context, but also on the expected behavior of the other opponents. And especially this expected behavior of the other opponents is one of our focus also in the RELAI project. So these are really old movies from Germany. It's called Seven Sense. What we did before the project was starting, we analyzed more than 100,000 critical incidents recorded from taxis in Japan. And the benefit of this database, it's not that we only get video material from the front camera and also inside to the car, but we get also labeled from experts manual more than 100 labels about the traffic infrastructure, for example, which road type, but also about the behavior. For example, we have also labels inside where we can see if the opponent, the pedestrian, was drunken or not. And also the experts are labeling these situations, how critical it was. So sometimes we have accidents, for sure, but also sometimes the incident was really low because the opponent or the driver behaves in the right way so that it gets critical. Our partners from the institutes are focusing on this human behavior. So on the right side, we can see a video which shows that inside the vehicle, the AI-based algorithm recognize the activity of this person. So you can read hardly in white what kind of activity he's doing, and we not recognize the laptop itself. We recognize, or the institute recognize, the whole skeleton of this body, and based on this behavior of the skeleton, he can define what kind of activity he's doing. And that's also the aim of this project, is to bring it in the virtual reality. So that means we have to make the combination. So we want also include these opponents, the pedestrians, also in the simulation. How it works, I will show now in the presentation. So the focus of the RELAI project is that at the end, we want to provide synthetic test scenarios which you can use in the simulation environment so that you can certify your autonomous vehicle systems or functions. And for sure, we have a lot of real-world data already available. So we have, I mentioned this database from Japan with more than 100,000 incidents, but also we hear today that a lot of activities are going on to capture a lot of data, and exactly this kind of data we are using. For example, we were also using open data sets from Wemo and Berkeley from US. And then we analyze this data set with our algorithm, which we generate out of these 100,000 incidents from Japan. It's called dynamic risk management algorithm. And with this algorithm, we can identify critical situations in recorded files, and then we provide these critical situations to analyze, for example, also the behavior of the opponents, and also to generate out of these critical situations in an automatically way the scenarios which you can run in the simulation environment. And at the end, that is what I mentioned, we want to have a holistic validation of the whole traffic situation, and that includes also that we include the pedestrian inside the simulation. So on the first step, we have to identify from the real-world data the critical incidents. Because, thanks God, in many cases, nothing happens. Because we are lucky and we are not at the same time at the same place. but sometimes it happens, and then we find out that a special behavior of the car happens, and this we recognize as an incident. And in Wemo and Berkeley, there are recorded more or less 100,000 traffic situations as well. And with our algorithm, we identify in Wemo 0.8% as an incident based on our algorithm automatically. And also in Berkeley, if we run our algorithm through the database, we identify 1.6%. So in this case, we filter out the really critical things when something happens, and this we analyze then in a further step. Here an example from a Wemo database, because suddenly this person on the left side is dashing out, and even the car has a green light, he has to stop. And that we recognize on the information, and also you can see, so the boxes, the object recognition, we not did by ourselves. We could use exactly also the Wemo database, because there are some data which are already labeled. And that's not, it's a really important information. What we did as next is we are using some algorithm to get a bird's eye view on the whole scenario, and also we identify the relevant objects which are moving, and we recognize the speed and the direction of the moving, so that you can also evaluate the whole process. And at the end, we generate, in this case, because we work together with IPG, we generate in a moment a file which describes this scenario in a generic way, so that you can import it into the IPG car maker, and then you can build up automatically this scenario. But the aim of this project is that we not limited to IPG, so we want to have an open scenario description, so that you can also include in other simulation environments. Because I think to generate realistic scenarios, it's really important that you also can verify and validate your systems with real things what happens on the street. So, and exactly here in this video, it's shown that also we built automatically this scene based on the Wemo database, and you can also see on the left side that there are the pedestrians, which one is moving. So we not manipulate this in a manual way. So in this way, the direction and the movement, and when he starts to move, it's exactly automated, included in the IPG. And we can increase the scenarios, for example, if you use digital maps. One other thing is what I said is that we not only want to put the situation in the simulation with the speeds and directions, we also want really to analyze the behavior of the pedestrian. And therefore, we also have the possibilities on the left side. You can see that we recognize with the 3D motion capturing how the people are walking around, and these people can have virtual reality glasses on their head, so they are also included in this situation, and so we can have real car in the simulation environment, so it's called X in a loop environment, and also the pedestrians are inside the simulation, so it's a really in the loop simulation, and so we can also find out if the expectation of the pedestrian and of the driver fits to what they want to have in this situation. And that's really important, that our autonomous driving systems and functions fulfill all the requirements what we have in our traffic today. So it's really a highly cooperated traffic in Europe and US. So it's really important that all the expectations are fulfilled also from the autonomous driving functions. So what I said is, at the end, we want to have this certification so that we have test scenarios which OEMs and suppliers can use to test their systems. And also we provide this, so we work together. So it's a founded project from the Federal Ministerium of Transport and Digital Infrastructure. And also there is a platform where we upload also these generated scenarios, so that it's open so that the people can use. And yeah, we are working together here also with the colleagues from Japan. So also here they are associate partners, and they are joining this project as well. You also can join the project, so please join the journey with us. So we have also a survey where we have different scenarios recorded, and we have some questions to you, how you are feeling in this situation, how critical you expect this situation, and so on. So that is where you can join this project as well. And at the end, thank you for your attention, and if you want to have more information, please contact me.
Thank you very much, Thomas.